So today we're going to talk about securing our web apps from a front end perspective, although there's not much that can be done from the front end, to be quite honest with you. Um, it's just that the front end is kind of the door to more serious vulnerabilities. And so the first thing I want to do is introduce myself real quickly, just so you know. Everybody probably already knows I'm Christina. Um, Best place to reach me if you ever want to talk to me is on Twitter, Night Shift C. At work, I write mostly client side JavaScript, but I also write Go and Python, more Go than Python, thankfully. And I also manage the bug bounty program and the vulnerability disclosure program, along with one of my coworkers. And then on the community side, I'm a former Code for Miami organizer. Code for Miami is a group that does civic hacking. If you're interested in making Miami better for citizens, I recommend that you check them out. I'm still a board member, but I'm not actively doing anything code wise. Uh, I'm the founder and co-organizer of Miami JS, along with David, who's my co-organizer, and Urbano, who's my other co-organizer, but is not here. And I'm also the organizer of NodeBots Day Miami. And we don't know how we're going to do that this year because it's pretty hands-on. So we'll try to figure that out. So the first thing I wanted to talk about is why you should care about security as a developer. I was on LinkedIn checking out a post by one of my ex coworkers, and she'd asked the developer if they thought that they were responsible for security in their code. And their response was that no, that the senior developers were responsible for the security, or the lead developers. And I thought that was like fake news for sure, because your your insecure code doesn't just affect other people; it affects you as well. And so there's some technical risks that are associated with it, which is these are just some of the risks. Destruction of data, data leakage, sensitive information disclosure, privilege escalation, and account takeovers. Privilege escalations generally lead to account takeovers, and that's very serious. But there's also business risks, which do affect you, because if your business suffers, they may have to lay people off, they may go out of business. And if you were just thinking selfishly, that's one good reason why you should care about security. It tarnishes your business's reputation. It puts your customers and potentially you and your coworkers at risk, depending on if it's like a internal app or whatever the case is. You lose customers, and there could be fines. And if you're subject to like GDPR and you have like a sensitive information disclosure, where there's PII involved, the fines are super hefty, like put you out of business hefty. So it's really important to care, even if you're a junior developer. So the first thing we're going to talk about is XSS. XSS stands for cross-site scripting, but actually it's just unintended script execution. And generally that's in the form of like JavaScript, but it could also be SQL injections and things like that. And so we're going to talk specifically about like JavaScript. And sorry if you hear my cat in the background. He's pitching up a storm. So the first exercise I'm going to talk about is a really funny one. This actually was pretty harmless, kind of harmless. So it's called Samy the MySpace XSS worm. And it's basically an XSS where this guy named Samy decided he wanted to have some fun, and he wrote this JavaScript here, which is, as you can see, kind of crazy. But essentially, what it did was it did three things. One is it added, when somebody would visit his profile, it added, but most of all, Samy is my hero, to their profile. And then it would also send him an invite, so that since it sent them an invite, he would become their friend. So he would have like a massive amount of friends, which was like the thing to do on MySpace back in the day. And then the third thing it would do is this script would actually add itself to the other person's profile, so that then when somebody visited that person's profile, the same thing would happen again. And so it became wormable. And in less than 24 hours, it had already added itself to over 1 million profiles. This guy got raided by the Secret Service. He ended up, he's a felon. He ended up having to pay between 15 and $20,000 worth of restitution. And MySpace had some pretty considerable amount of resources that they had to spend to fix this, even though it was still harmless, essentially. There is a good podcast called Darknet Diaries where Samy tells the story, and it's I recommend you check it out. I'll drop a link. And so the thing with XSS is that XSS on its own, a lot of you have seen like examples of XSS where it's just like somebody alerts a zero, and a lot of times you don't see why XSS is so serious. But these these are some big companies that paid researchers for exploits that they found, and so um, Facebook paid $25,000 to a researcher because they found that with an XSS chained with post message, which is another front end web API or web API, they were able to do an account takeover. So somebody was essentially able to use an XSS and post message to take over your Facebook account. Um, Apple paid almost 300 grand. This was for a slew of different exploits, but two of them happened to be XSSs, and one of them happened to be wormable, and it was a wormable iCloud account compromise. And so it was similar to the Samy worm in terms of the fact that it just self-propagated, but it was compromising iCloud accounts because it was chained with a lack of segmentation, which means that they were using their iCloud mail server. It was sharing with like their iCloud photos and a bunch of other stuff rather than being separated. And so when they were able to compromise the mail through an XSS, they were then able to compromise people's photos and other things. And then the final one, as an example, is Instagram. They paid a researcher who was 14 years old $25,000 because he found an XSS that was chained with an open redirect, which could be used as a malicious redirect. And with a malicious redirect, basically what they're doing is they're redirecting you to another site. When you get to that site could be installing a keylogger, it could be installing malware, it could be doing any number of things. It could be doing a CSRF, which we'll see later. Um, so XSSs, when they're chained with something else, is when they become pretty dangerous. Um, Otherwise, there's other things that can be done, which I'll show an example of, like a defacement that can be done with a CSS that doesn't require chaining really with anything else. And so here I just showed some tweets. These could be tweets. It could be text messages, WhatsApps, Skypes. I know everybody's gotten like that Skype message from somebody at random that's just got a link in it. It could be an email. It could be anything. I just put some tweets here because it was easy. But and then I'm using like this like my URL shortener because URL shorteners are super simple to create, and you could just create a URL shortener that allows these payloads. Because if you use a URL shortener like Bitly or Tiny URL, they're privy to this, so they protect against it, which is really good for all of us. Um, but it's really easy to just create your own shortener and then hide this kind of stuff. So the the stuff that's happening after the query parameter here, after the Q parameter, is it's just an image tag that has a source that doesn't have a value. And so the image tag has a on error event handler that can be used on it. And so when the image doesn't have a source, it's going to error. And so it's going to call that error. And that on error is basically a JavaScript function. And it's going to evaluate anything in its values as JavaScript. And so in this case, this first one is just a window replace, which is just a redirect. And so this could redirect to a malicious site. And so the second one, it's the exact same payload, except that in this case, instead of using the window replace, the location replace, it's using a fetch. and it's going ahead and it's fetching this webhook site that I like. It's really cool. If you ever need to test something out, you can add like you can add like query params to it and pass values, and it'll automatically show up. And then the final one is just a defacement, and that's all it's doing is just changing the body's inner HTML to something else. And so I'm gonna go ahead and show you those. Yeah. So this is the website, the webhook site, which is pretty cool. And so once webhooks get hit, they'll show up here. And I'm just gonna refresh it. It's kind of slow. And because I'm lazy, I've already got these here. So I'm gonna go ahead and do the JWT first. And you'll see, so actually let me tell you about OWASP juice shop real quickly before. So OWASP juice shop is it's a vulnerable app. It's purposely vulnerable so that developers can use it for learning about different exploits and how to find them and how to fix them and stuff like that. And so I'll show you here. So here's my webhook that just came from that exploit. And so the reason that exploit is possible is because OWASP has this right here, which is that's that query string right there. And so then it does a search, but it's susceptible to XSS. So that's why you can see that I'm just putting this image here and it's alerting 0. And so in this case, what I did was I just created a different payload using the same image, and I just made it so that it's fetching this website. You see a lot of gibberish here. This is all just encoding for URIs. Obviously, there's things that you can't use like question marks and slashes and stuff when it's behind the query param. And so should have 2 here. Yeah. So in this case, what happens is I sent myself the JWT token, and I'm doing this all manually, but a bad actor is going to be doing this automatically. They're going to have scripts that are doing all of this. And so in this case, I've got this JWT token, and this JWT token, if you know about JWT tokens, then you know that it gives you implementation details. So it tells you what algorithm is being used. It tells you the type in the header. It gives you a payload and it gives you a signature. So the important thing here is the payload. This payload gives us some PII already. So we've got an email. We could potentially have a username. So if you have and we have a password. This is a hash, but there's tools out there that can crack these hashes. There's Hashcat, there's John the Ripper. If this is an already used password, it's even faster. And then this could be used for like password spraying and stuff like that, where they're just like brute forcing your login and not only yours, but other websites, because they know that people use the same username, the same email, and the same password on multiple sites. It's also got a role here, which means that you could change this. So in this case, I'd already changed it to admin, but this was customer before. And then it's got this deluxe token, which on this app is just like a special feature that customers have, or whatever the case is. And so you could potentially add, like if you got a deluxe token from another user, you could add it to your own user, and then just recreate your JWT token. And a JWT token is essentially just base 64s. So these are just base 64s right here that are encoded. And so that's why it just breaks it down here. And you could use something like CyberChef. And you could just like grab the payload part and to base 64. Sorry, from base 64. And then you could just grab this, and now you could go ahead and change it to whatever you want. So you could, change your email, change whatever the case is, and then you just turn it back into base 64, and you can try to see if you can exploit that. In this case, with OWASP, you can exploit it, and you end up getting access to like the admin panel. And there's just a lot of things that could happen if you have a misconfigured JWT token plus an XSS. All right, and so we'll go ahead and go ahead and close these. In terms of the redirect, this is pretty simple. It's just gonna take me to the site. And then in terms of the defacement, it's just going to deface the website. All right. So the only answer to XSS is trusting no one. It's best to assume bad intentions, even though your users may not have bad intentions. They're not the only ones that have access to your site. And so some of the things that you can do to mitigate XSS is validate all your user input on the back end. A lot of times people do their validation on the front end, and that's just not good enough. There's some things you can do on the front end, but they're definitely just icing on the cake. Make sure that you're using like a tried and tested validation library. Something like Express Validator or Validator.js in Node. Golang and Python all have similar packages. And make sure that it's not just your user inputs in terms of what you think of as user inputs, but also like cookies and request headers, because those are actually user inputs as well. When you're using an app like Postman or something like Burp, which I'll show you later, you can change all these values. So you can change it to whatever you want, and you can actually put malicious payloads in there as well. Use DOM Purify for sanitizing all your user inputs that are going to be reflected in your HTML or used in the JavaScript. And that includes input fields, including the hidden ones, which we always forget about, stored data from your database or APIs, URL query params. As you saw, we just exploited those and did a couple of different things. And SVGs. SVGs are actually just code, and you can actually put JavaScript in there and it'll execute. And with your stored data from your databases, APIs, and things like that, even if you are validating user inputs on the back end, that doesn't mean that you were always doing that. So it's good to just be safe in case you happen to have some legacy inputs in there that maybe were not validated and could be malicious. Because sometimes you're testing your app, and you're putting things in there, and you're looking to see if you have like a reflected XSS, which means that you're causing this XSS to happen on this page, but that doesn't mean that this data isn't going to be used in some other place later on and then have an XSS there. Avoid using unsafe HTML directives in your JavaScript frameworks without solid sanitizing like DOM Purify. And even then you have to test. But Vue, React, Angular, and they'll all have this. Vue has a directive called vHTML. React has a method called set inner HTML dangerously or something like that. I might be mixing up the words. Angular has both a directive and ngHTML, and they also have something similar to React, a method which I don't remember the name. And Svelte also has HTML, which evaluates HTML, and it evaluates JavaScript because it's in a JavaScript context. So they'll actually warn you. They all do this. Well, Angular doesn't, but they all do warn you that they're not sanitizing the expressions, and that you're gonna be exposed to XSS, so you have to sanitize. Vue also warns you, and so does React. And then when you're using Vue or React, Angular, whatever, you're generally using also UI frameworks that also have JavaScript. So for example, Vue has a library that's called Vuefy. that you can use for components like notifications and things like that. And so sometimes these libraries are using things under the hood that unless you read the code, you're not going to know, or unless you actually test them, you're not going to know. So whenever you're going to use a component from a UI library, make sure that you're testing it. So in this case, I'm going to show you an example of BuFi. So BuFi, this is a real simple, it's just a button calls this function called success here. This function is taking this, oh, wait a minute. What happened there? Ah, there we go. Cool. So it's taking this, it's finding this XSS query param right here, which is the same payload we've been using everywhere. And it's adding it to this BuFi's notification component message. And so if this is a user input, which a query param is a user input because the user can modify it, and it evaluates the HTML, it's going to XSS. So this could again be something more serious, right? I'm just alerting a zero, but it could be an open redirect. It could be any number of things. It could be stealing a token. It could be stealing a cookie if your cookies are not safe, and things like that. And so the reason that this happened is because BuFi is using VHTML under the hood. So this is their notification component. And they're using VHTML for that message that you used. And so essentially you became susceptible to XSS and you didn't even know it, because I know I do not read every single line of code from all the UI libraries and things that I use. And I am 100% sure most developers do not, because there's just not time for that. The final thing is to implement the content security policy header. And I'm going to talk about that a little bit. So there's a lot of best practices. These are not all of them, but I'm going to talk about these because these are probably some of the most important ones. Using the principle of least privilege, which is a good practice in a lot of scenarios, but specifically in the case of the content security policy, that means just using self. And self, it basically means just using only resources from my domain. So the domain that's making the request has to match the domain for that resource. So if it's a JavaScript or CSS file, it's going to have to be from the same domain that you're actually on. And then only add things as they're necessary. So if you have like a CDN that you're pulling some files from, then you would add that. And I'd encourage you to maybe have your own CDN, or even use files locally if you can, versus using these public CDNs. One, because you don't know their security posture. You don't know what they're vulnerable to, and two, because sometimes they just go down and then your JavaScript's not working, and that sucks. It's happened to me. And then the second thing is you shouldn't use safe inline. You should try to avoid it as much as you can. Safe inline means that you're going to be able to do inline CSS and inline scripts. So like you'll be able to have like a style tag, or you'll be able to have like a script tag, and then you'll have like JavaScript in there that'll run. You wouldn't be able to do that if you don't have safe inline set up. If you're gonna do that, make sure that you're using a nonce or a hash with your safe inline, so that it knows which scripts are whitelisted based on those things. And so like a nonce is just a number used once, which is like a random number that's generated on the fly each time. And a hash is just a hash similar to like what you would do for like a password or something like that. And that's also like a one-time thing, and it changes. And then you can use the report to directive to monitor, configuration bugs and attack attempts. So one of the things with security policy, and the reason that sometimes people don't adopt it, is because they've heard about people implementing it and then having a bunch of bugs because they configured it incorrectly. So you can use the report to directive to monitor if you do forget to add a CDN, for example, or if you forget to that you have some inline CSS somewhere or something like that. And you can use report to just write to, like, I don't know, you could probably use CloudWatch, I guess, or whatever monitoring tool you use. And you could also just monitor like attack attempts and see like where are people attacking the most, and then that way you can put some resources on trying to strengthen that particular area. And so I'm actually going to demo real quickly CSP, and we'll start with the code. So I've got here, I'm going to be using Helmet, which is it's a Node.js module for setting a plethora of security headers. You should definitely check it out if you're doing Node or something similar to it if you're using some other language. But there's a bunch of other headers that you should also be implementing. I'm only going to show the content security policy today. But so this is just a basic little Node.js server. I've got this this route here, CSP, which is just going to be a little form. And then I've got these two settings here. I've got safe HTML, safe helmet config, and I've got an unsafe helmet config. So we're going to start with an unsafe config, and I'll show you the JS real quickly. So it's just like I said, a little form. It's got an unsanitized input. I've already got a value in there with that same payload that we've been using because I'm pretty lazy. And we'll go ahead and try submit that. And then we've got some inline styles right here. So all this does is set the body text to hot pink. And we're loading a couple of JavaScript files. One is a self file, which is just a file that's on our domain. And we've got another one that's coming from a CDN from Cloudflare here. All right. All right. So this is that form, and let me go ahead and do that up. All right, cool. So here's an XSS. It works, and as you can see, we're not getting any errors here. Everything's fine. And if you notice, our Axios loaded fine. So did our main CSS. So did our main JS. And our text is hot pink. So it did use our inline style. So if we change that, we go back to the server and we change this to safe. On the safe, I'm not allowing inline for JavaScript or style. I'm pretty much just setting everything to self. I'm just setting the default source. That's your scripts, your styles, your images, iframes, all kinds of stuff. You have to kind of look at the whole list and make sure you configure it correctly. And I'm not even allowing this Cloudflare here. So this Cloudflare is also going to fail. So I'm going to go ahead and refresh this. And the first thing you're going to see off the bat is that this inline style no longer works. It's black. And if we look here at the console, you'll see that it refused to apply the inline style. And you'll also see that it refused to load the script from the CDN. And if we look here, you'll see Axios was blocked by CSP. Don't mind that favicon. That's just, I didn't do that. And then if we try to run this XSS, it's going to refuse to execute inline event handlers. So it refused to use that on error that's on that image payload. So this is definitely like a really good layer of protection for XSS. It's not the end all be all. It's not something that by itself will protect you from everything, but it definitely is a great layer that you should definitely consider. I'll show you one other thing in case you're risk averse and you want to start slowly. There is something called report only in the content security policy header directives. And what that does is it allows you to go ahead and, it allows you to implement the headers without any of the side effects. So stuff is still gonna, let me just do do this one more time. So stuff is still going to load. Your access is still going to load. Your inline CSS is still fine, but it is going to report it here. And it is going to say like, I'm reporting only that I would have refused this inline style. I would have refused to load the script, and I would have refused to execute this inline event handler if this wasn't set to report only. So report only is a good way to get started, and kind of maybe a month or so before you want to actually implement the CSP, just put it in there, use it with report to, and start monitoring. And it'll kind of collect a list of everything you're going to need to take into account based on these reports. So that's CSP. If you have any questions, don't forget to just drop them in the chat, and I'll definitely try to answer them at the end. All right. So going back to when we talked about the Vue5 UI library, um, this is a very similar issue, and this is actually very common. A lot of people become susceptible to attacks like XSS, for example, through npm modules that are, either dependencies of, or actually exploits in a package that you're using as a direct dependency of your app. And so there's a couple of ways to fix this, and none of them are hard or time consuming. One is you can run npm audit, and it's going to give you a list of all the npm modules that have vulnerabilities, whether they're critical or low. And I think there may even be informational. And you can run npm audit fix on it, and that'll actually fix. It'll update any dependencies of your dependencies that are compatible. So if you're using Vue 2.5.1, and then that has a dependency for some module, it's going to get the latest version of that module that is compatible with 2.5.1. And then the best way is to use npm update, which will actually just update your modules, your actual direct modules. So like in this case, Vue and Vue router. And so you'll notice here that on the left, I've got the same dependencies that I have on the right, but there's one difference, which is there's a caret. And so that caret represents how this is going to update. So in the case of the left, your Vue and your Vue router are going to be stuck at that version no matter what. Even if you run npm update, they're still going to stay there. But if you run npm update with the right hand configuration, it's actually going to update to the latest minor version, right? So if the latest minor version of version 2 of Vue is 2.6.4, then it's going to update to 2.6.4, even though it still says, caret 2.5.1, and the same for Vue router. The benefit of that is that you're going to get the latest, features, but you're also going to get the latest fixes and latest hot fixes. If you haven't worked with Semver, I'm sure you all have, but if you haven't, the first number is going to be your major version. That's where there's breaking of compatibility and stuff like that. Then you have your second number, which is your minor version, and you shouldn't be breaking compatibility there. So you should feel pretty safe. And then the third one is just going to be like hot fixes and patches. So those are definitely things you want. So worst case scenario, if you're kind of risk averse, you could use the tilde, and the tilde is only going to give you the hot fixes, which is only the stuff that's happening in that last number. And a lot of times, security fixes will be there, especially if they're very, very serious. Right. So the next thing I want to talk about is CSRFs. And CSRFs are called cross-site request forgeries. And basically what it is it's just when one website is able to make requests to another website that it shouldn't be able to make requests to. So in this case, I'm using the ethicalhacking.sh website as an example. It's not malicious, but let's say it was. So you find the link on Twitter, and you want to read this article, and you go to this page and you're reading the article, no problem. Under the hood, there's a hidden form and there's some hidden JavaScript. And if you notice on line 7, it's submitting itself. So as soon as the DOM loads, it's going to go ahead and submit this form named CSRF to this vulnerable.com, which is not ethical hacking.sh, right? And it's going to be doing a post, and it's going to be sending a malicious value. And this is a pretty rudimentary example, just to kind of get the point across. But this could be anything. It could be creating a user account. So it could be creating another admin if this is like a multi-tier role-based web app. It could be changing somebody's password. It could be changing their email. It could be changing their username. It could be doing any number of things. It could just be, if it's a get, it could just be grabbing sensitive data. So um, so there is a cookie setting that when it came out, made a lot of people say that CSRF is dead. But the fact is that it's definitely not dead. It's still pretty common, and a lot of times CSRF tokens are like misconfigured or not done correctly, and so people are like resting on something that's possibly not gonna protect them completely for a couple of reasons. So there's 3 settings on the same site cookie attribute. One is none, one is lax, and one is strict. I've got an asterisk on lax because there's a few browsers that do set lax by default on all your cookies. Um, but Safari and most mobile browsers do not. So you can't actually count on lax being set by default. You should actually set this explicitly um, in your cookies. None basically means, so same site basically means like, what am I, what am I sending? What cookies am I sending when I make a request? Um, and so with none, requests send all cookies. So if somebody was to have that form on their website and make requests to your website from that form on their website, it's gonna send all the cookies if you're authenticated. So you definitely, absolutely, 1000% need CSRF tokens in this case. The cons are just everything. Like, there's zero protection if you're using same site none. You might as well not use it at all. And that is the default for some browsers. So lax is the other setting, which is I think it's probably the sweet spot. Um, and so this one will send cookies for your get requests. And so in this case, tokens are recommended because there's 2 different scenarios. One is get requests could still contain sensitive data. For example, it could be an endpoint for users, and this endpoint for users could have usernames, users emails, their phone numbers, PII data, things like that. And the other is something that a lot of developers have probably seen, which is that not all endpoints or not all APIs respect HTTP methods. And in some instances, either they're using rudimentary routing and then it's just a function that runs and it doesn't care what the method was, or they're using get methods to change the state in their databases and things like that. And in that case, since Lax does send the cookies for get requests, it will be able to prove authentication. And then if you're just relying on a cookie being there, it's going to do what it's going to do. And then the final setting is strict. And that means that it is sending no cookies nowhere. So in this case, CSRF is actually dead, I'd say, with 99% confidence. But the con is that it's a UX nuisance, because if somebody links to your site from a 3PD link, they're gonna, even if they are authenticated, when they land there, it's gonna appear as if they're not authenticated, and they're gonna have to log in again. So that's kind of annoying. Um, And so I'm gonna go ahead and demo that real quickly as well. So let me show you guys the code here. Okay. All right, so here we've got, it's kind of hard for me, my mouse is not working, sorry. So on line 42, we've got this cookie value, which I'm gonna be setting when I get the CSRF page. And it's just gonna set a cookie, and I'm gonna go ahead and set this to, I'm gonna set it to none. And then we've got a couple of endpoints. So we've got this post endpoint, and we're going to be looking for that cookie versus this cookie value up here in line 42. And then we've also got a get endpoint, and we're going to be doing the same thing. So in the case of the post, if it's successful, we're going to go ahead and just send this message received message, and it's going to just drop right on the page. And in the case of the get, we're going to go ahead and show this sensitive data from this JSON API. All right. So let's go ahead and do that. And hold on, guys. My mouse is acting up. Oh, man. All right. There we go. Sorry about that. All right. So let me go ahead and refresh this, and let me make sure these cookies are gone. Cool. Firefox is a little weird about their cookies. So we've got same site set to none here. All right, and so I'm going to show you how this works. It's going to show this message. And then for the get, it's going to go ahead and just show that sensitive data. So this would be like considered PII, right? And so if I use a tool like Burp, so Burp is, sorry about that. Burp is a proxy. What the hell? Jeez. Okay. So Burp is a proxy that allows you to intercept requests, and then you can actually make changes to them. So this is like what a request looks like. It's just like curl. You can change whatever you want, which is why I said that, you know, headers and cookies are actually user inputs at the end of the day. But Burp allows you to do some, wow, if I could, there we go. So it lets you do this thing called a CSRF proof of concept. And so it essentially goes ahead and it creates the form for you. Oh, and I'm having a really hard time here. Oh, man. Oh, there we go. All right. So it creates this proof of concept for you, and it lets you test it in the browser. So I'm going to copy that, and then I'm going to go here, and it's going to create a form for me in a different domain. So this domain is going to be burp versus my 127.0.0.1, just to show that it is cross-site. And so this form, when we hit it, it went ahead and it gave me that sensitive data, even though it started out at a different domain. And then this was with a get with a post. So with a post, all right, I got my mouse back. We would do the same thing. It's gonna generate a post. It's gonna be going to this, but it's gonna be coming from a different domain. So there it is. And so that's my malicious test. So if you notice here, this was the payload that I used, malicious test. And so We're gonna go ahead and change this to lax. I'm not gonna show strict only because strict is the same thing as lax, except nothing's gonna work. Um, so now go ahead and clear these cookies again. Yeah, Firefox. Oh, that's crazy. There we go. All right. And so now, let's see. Cool. So now it's lax. And so we're gonna go ahead and do the same the same exploits. And I'll go ahead and grab the same one. This is the post. So on lax, post won't work. And so we go back here and we try this now. It didn't send the cookie. So now the cookies don't match. The person's not going to be able to, create a new user, do whatever they would be able to do with said endpoint. And then if we do a get, um, it is still going to work, which is why in the case of gets, you have to be really careful unless you're like 1,000% sure that your API is perfect. You want to use CSRF tokens. Um, there's my sensitive data, even though I'm using the lax. If I was using strict, this wouldn't work. But again, you've got that UX thing where a user is going to appear to be unauthenticated if they're coming from another site that links to your site, and that might be something that you can't take. All right. So that's CSRFs. Again, if you have any questions, drop them in the chat, or you could ask them at the end. I'll unmute. And so finally, I only talked about a few exploits and a few things that you could do to fix those. But there is a plethora of exploits and vulnerabilities that could happen on your web app. Too many to spend more than less than an hour on. So there's things that you can do because you don't know what you don't know, which is layer your defenses. So in the case of, for example, the cookies, or in case of the CSRF, use your CSRF tokens and use the same site because they're going to help protect you. So that if a bad actor does find a way around the CSRF tokens, you've still got your same site, and at least you're not as exposed as you would be if you didn't have them. You might still be a little bit exposed, but not completely. Um, and in the case of like XSS, there was a lot of things that you could do: validate, sanitize, use CSP, and other things. Um, when you're implementing a new feature, research the security best practices and vulnerabilities for it. So if you're implementing like JWTs and you've never done that, or you haven't done that in a long time, research the security best practices and the vulnerabilities so that first of all, if you've never worked with it, so that you know just in general, like how should I do these things and what could go wrong and how do I test. um, and in the case of if you haven't worked with JWT tokens in 4 years, then a lot has changed and there could be new vulnerabilities and you want to know about them because you want to make those test cases, which leads me to my next point, which is include vulnerability tests in your test cases. Um, check if people can access things that they shouldn't be able to access. Um, Test XSS. There's a lot of different payloads you can try. I'll share a resource for that. There's a whole post that gives you a bunch of different ones that you can try. And finally, if you can, start a vulnerability disclosure program, which will give people permission to test your web app in the ways that you allow them to. So you can actually create like a program guide where you've got like, okay, you can use our staging environment, and this is how you create an account, and these are the things you can test, and these are the things we're interested in, and you could make it very detailed. And you can do that with a company like BugCrowd or HackerOne if you um, wanted to. They manage it for you. They have people that do triaging, which is pretty cool because they'll spend the time to make sure that these are actual bugs versus them coming straight to you and you having to do that. But if you can't afford to do that, Then start with something small and give away swag. People love free T-shirts, and it's a good way to find out about vulnerabilities that you're not aware of. Um, and yeah, you just have to get buy-in, which is the hardest part. So that's my presentation. And so I'll take any questions anyone has, or if anyone wants to make any comments, feel free.